Good afternoon to everyone. Today class is origin of igneous rocks. So in that we have two topics. Those are differentiation. First one is differentiation and second one is assimilation. So first of all, what is differentiation? So differentiation of magma, right? So the process, right? First one. So the process by which magma splits, right? Magma splits into parts having different composition, that is called differentiation. So these parts on cooling and solidification produces, that is, different types of rocks. So it takes place during this cooling of magma, right? So, and which magma splits into parts of different composition. So that is called differentiation of magma. So this differentiation of magma is done by some different processes. So those are 5 processes. First one is fractional crystallization, and second one is liquid immiscibility, and third one is gravity setting, and fourth one is gaseous transfer, and last one is filter pressing. So these are the some different types of process in differentiation of magma, right? So now we are going to learn one by one. First one is fractional crystallization, right? So as magma cools, early crystals settle by gravity and melt composition changes as a result, right? So as soon as magma starts crystallizing, right? So that is drift begins. So it is done in 2 ways. That is through localization of crystallization, right? Crystallization. So, and that is second one is relative movement of crystals and liquids, right? Crystals and liquids. So crystallization means to crystallize or to get form of crystals. Get form of a crystal, right? So crystals are formed of magma in 2 ways. First one is through the localization of crystallization, and second one is relative movement of crystals and liquid. So first one means localization of crystallization. It means this crystallization happens at some particular site, right? So, and relative movement of crystals and liquids, that means when crystals and liquids move upward, right? Move upward. Then also crystals are formed. So this is called fractional crystallization. Right? So fractional crystallization is the removal and segregation from a melt of mineral precipitates. So which changes the composition of the melt. So this is one of the most important in geochemical and geophysical processes that is operating within the earth crust and earth mantle. So fractional crystallization in silica melts, right? Silicate melts, that is a very complex process that is compared to chemical systems in the laboratory. So because it is a affected by a wide variety of phenomena. So the prime amongst, so these are the okay. So these are the composition and also temperature and pressure of magma. So during its cooling, right? So the composition of magma is the primary control on which mineral is crystallized as the melt of cools down past the liquids, right? Right? So for instance, in mafic and ultramafic melts, so the MgO, SiO, right? So magnesium oxide and silicon, SiO2, silicon dioxide. So these contents determine whether forestine olivine, so that is precipitated, or whether anesthetate pyroxene, so that is precipitated. So the two magmas of similar composition and the temperature at different pressures, it may crystallize different minerals. So for example, high pressure and high temperature fractional crystallization of granites, that is to produce single feldspars, right? Feldspar granite. And low pressure and low temperature conditions, so that is produced two feldspar granite, right? Two feldspar and granite, right? So the partial pressure of volatile phases in silicate melts, that is also of prime importance. So especially in a solidus crystallization of granite, right? So you see here iron, magnesium and calcium. So those are removed in early settled solids. And silica, aluminum, sodium and potassium, so these are remain in melt in increases in abundance, right? So fractional crystallization is over. And second one is, what is that? Liquid immiscibility, right? Liquid immiscibility. So this immiscibility, what is the immiscibility? Immiscibility means they cannot mix with each other, right? They cannot mix each other, right? So a mixture of, right? You see here, a magma, it may split up in two immiscible liquid fractures of different compositions like oil and water as a result of cooling, right? So subsequent crystallization of these immiscible parts gives rise to different types of rocks, right? So liquid immiscibility, a mixture of two different compositions, right? It may be homogeneous at temperature, but with falling temperature, both of them become immiscible, right? So a magma, it may split up into two immiscible liquids like oil and this water, right? Oil and water. And it gives rise to some different kinds of rock causing different, right? Oh, for example, you see this picture. So this is oil and this is water. So a mixture of oil and water, it could be homogeneous at a temperature, right? So, but when the temperature falls, they will become immiscible. So they cannot mix with each other. You see, this picture is very clear here, right? So a magma, it may split up into two immiscible liquids like oil and water, gives rise to different kinds of rocks. That is causing differentiation. So a different kind of magmatic segregation involves liquid immiscibility, right? So a cooling magma, it will sometimes precipitate droplets of second magma. So that has an entirely different compositions like oil in this water. So the two magmas will not mix, right? So this is the liquid immiscibility, right? Next one is gravity setting. So what is the gravity setting? A phenomena in which a temperature gradient in a mixture of fluids give rise to a flow of one constituent relative to the mixture as a whole, also known as the thermodiffusion, right? So stable and persistent stagnant boundary layers have been shown to occur near the top and sides of the magma chambers. So heavy crystals. So the heavy crystals are formed during early phase of crystallization sink down. So those crystals are formed as a crystal that are formed during early phase of crystallization, right? Early phase of crystallization. So they have turned into to sink down, right? Sink down. So the process of sinking, so that is controlled by viscosity of magma. Viscosity is friction between the layers of magma. So, and by shape and size and also density of crystal. So, and settling of crystals under effect of gravity, that is an effective process of differentiation, right? So the next one is filter pressing. So what is the filter pressing? So crystal fractionation is the separation of crystal from the melt either during or after their crystallization. So crystal fractionation is occur mainly three ways, right? So I will tell this. So what is the crystallization? Filter pressure. So it result, then what happens? It pressure is acted, then crystallizing magma. It separated the fluids and the solid part. So that is called crystalline magma, right? So filter pressing, so this process that occurs during the crystallization of intrusive igneous rocks, right? Intrusive igneous bodies, so in which the interstitial liquid, so that is separated from the crystals by pressure, right? So as crystals grow and accumulate in a magmatic body, so a crystal mesh may be formed, so with the remaining liquid distributed in the insecticides, right? So this is the filter pressing. Next one is, sorry, I forgot this, gaseous transfer. So gaseous transfer, that is when pressure is released, right? Pressure is released gases and volatiles. So they are come upward. So they move towards the direction in which the pressure has been less, right? So this generate convection and causes separation or differentiation. So that is due to this, what happens, the convection, so current that is generated and differentiation is occur. So we know convection, and convection is transfer of heat, right? So that is gaseous transfer, right? So this is the differentiation, right? Differentiation of magma. And next one is assimilation. So assimilation, what is the assimilation? Assimilation is the process of reacting of the magma. So with the ball rocks, so whereby the country rocks, those are incorporated in the magma and eventually melt. So magma is magma rising from their site of origin react with or melt and mix with the wall rocks in the magma chamber. So this is called magma chamber, right? You see this picture? Okay. So assimilation is the reaction of the magma, right? Reaction of the magma with the wall rocks. So whereby country rocks, these country rocks are incorporated in the magma, eventually melt, right? So for this process, that is to become an efficient mechanism of differentiation. So, and relatively large amount of the country rock have to be assimilated by the magma. Assimilated by the magma, or the composition of these country rocks have to be drastically different from that of the magma. So this process is called assimilation, right? Assimilation. So we have another method in this assimilation. So that is of creating different daughter magmas from a parent base having the later react with its wall rock. So that is considered a magma that is crystallizing pyroxene, right? And labradorite. So if the magma tears from the its wall minerals, let's say olivine and anorthite, so which are formed earlier than pyroxene and labradorite in the before I told in Bowen series, right? Bowen reaction series. So they will react with the liquid that is to form these same minerals. Those are pyroxene and labradorite. So these same minerals with which the magma is in equilibrium. So the heat for driving this reaction comes directly from the magma itself. So, and more pyroxenes, right? More pyroxene and labradorite. So it will crystallize during the reaction and it will release their latent heats of crystallization. So, and then next one, if a mineral, for example, you take quartz, right? Quartz. So quartz formed at a large stage, then pyroxene or labradorite falls from the rock walls, right? Rock walls into the magma, right? So the latent heat provided by further crystallization of pyroxene and labradorite, it will cause it to dissolve. So this is situation. It will occur only if the this quartz from the wall rock that is at a lower temperature than the magma. So it will cause the magma that is to transfer its heat to the quartz in a cooling process. So this cooling of the magma, it will necessarily be accompanied by the crystallization of the minerals that is already in present. So in both cases, the composition of the parent magma, it will be changed by the country rocks. It may contribute, you see here, xenoliths. Right? These are the country rocks. So xenolith contamination. So this contaminant need not belong to the reaction series in order for it to cause reactions or dissolution. So in most cases, the end result, it will be a shift from the original composition of the parent magma, that is towards that of the contaminant. So this process in which wall rocks, those are incorporated into the magma. So that is called assimilation, right? Assimilation. So because assimilation is accompanied by crystallization. So it is likely that both fractional crystallization and assimilation, it will take place simultaneously. So this combined process, what is that? Crystallization and fractional crystallization and assimilation. So this combined process that is referred to as AFC for assimilation fractional crystallization. It has been processed at the mechanism by which andesites, right? Andesites. So these are produced from the basalts, right? So if they are not digested, they remain entrapped within the mass of crystallized magma. Such entrapped fragments of country rocks, so those are called xenoliths, right? So as assimilation involves, that is remixing of magma. In the magma, it may be considered as reverse process of differentiation. So assimilation causes variation in complexion of in igneous rocks, right? So evidence for assimilation, you see this as magma process upward, right? I already told this, upward through the earth crust. So pieces of the country rock through which it passes, it may be broken off and assimilated by the magma. So contamination of magmas by country rocks, it may contribute xenoliths, right? Xenoliths and xenocrust to the magma. So the presence of xenoliths does not always indicate that assimilation has taken place. But if the xenolith shows evidence of have been disaggregated with the minerals distributed through the rest of the rock, so it is likely that some contamination of the magma has takes place, right? So these xenoliths and inclusions within the plutonic or volcanic rock. You see here, these are, right? So that is provide evidence for the assimilation process. So the best evidence of assimilation comes from our studies of radiogenetic isotopes such as rubidium strontium system, RBN SR system, right? And you see this real picture of, this is classic xenolith, this is classic xenocrust, right? So assimilation is a thermodynamic process that is involved the following. Principles, that is heat of solution equal to heat of melting, heat of mixing. So this is the principle of assimilation thermodynamic process. So where heat of solution, so it means heat of solution is the, this is ability, right? Ability of magma, that is to dissolve and inclusion. And heat of melting, this is heat of melting. Second, heat of melting is the heat capacity of the solid phases plus the heat of crystallization of the mineral involved. And heat of mixing. Heat of mixing means, so it is the heat required to mix the phases, right? Heat required to mix the phases. So this is the principle of assimilation thermodynamic process. And you see some pictures here, this one and this one, right? So xenolith and xenocrusts. So assimilation consists of three processes. What is that? Melting of wall rock and dissolution and diffusion of wall rock. And third one is reaction of fluid and wall rock. So what is the melting of wall rock? So melting required it considerable amounts of heat, right? So that heat required to melt the wall rock, it has two essential components, right? So first one is heat energy necessary to raise the temperature of the wall rock to melting temperature. And second one is the latent heat of melting, it must be added to the system before the rock will melting. And if assimilation is to occur by melting, then what is that? So those are the magma, it must be superheated to provide substantial amount of heat without freezing. You remember this, without freezing. And then next one is large quantity of magma, it must freeze to provide enough heat to melt the wall rock, right? And third one is only hotter magma will assimilate cooler wall rock. So these are the melting of the wall rock process. And diffusion. So what is diffusion? So diffusion means solid state diffusion. So that is very slow, right? So therefore, the effect it may be limited, right? So however, the breakup of wall rocks, it can significantly increase the surface areas, and diffusion, it can become effective. And this dissolution requires that the magma, it be undersaturated in the component to be dissolved, right? And reaction of fluid and the wall rock, right? So the reaction, that means that requires ionic exchange between the magma and the wall rock. So reaction is favored by the chemical potential gradient in contact zone, and reaction is governed by the type of alteration that actually proceed, and wall rock composition, and pressure and temperature of the environment. So this is reaction governed by these three types, right? And examples of assimilation. So for first one, basaltic, right? Basaltic liquid assimilating a granitic solid consisting of quartz feldspar, right? Quartz feldspar in plagioclase and alkali feldspar, and also biotite feldspar, right? So those will be melted, right? So the heat for melting comes from the heat generated by the crystallization of olivine and pyroxene from the liquid. So not from the temperature of the basaltic liquid. So only heat generated by the crystallization. So this granite inclusions will not be completely melted. So that is called partial melting. So, and that result is a basaltic andesite, and with inclusions of chewed out, that is partially digested granitic material. So for the reverse process where granite liquid incorporates basalt, so and anhydrous minerals in the basalt. So those are olivine, pyroxene, and plagioclase. So these become altered to micas, amphiboles, and epidote by the addition of H2O. So the heat of crystallization of quartz, feldspar, and biotite from granitic liquids, those are not large enough to melt the basaltic intrusion. So that is resulting in very minor changes in the original liquid composition. So the result is a granite with amphibolic inclusions. So any changes that is caused by assimilation and hybridization, so those are dependent on the nature of the inclusions and the nature of the magmatic liquid into which the inclusions are in place. So these are the examples of assimilation. So how foreign rock matter are incorporated by the magma? First one is the incorporation of foreign rock that matter by magma. So this is occurred in three ways. First one is mechanical incorporation without chemical reaction, and second one is reactions involving partial solution of the incorporated matter and the precipitation involving the replacement of one solid phase by the another. And third one is total dissolution involving the total disappearance of the solid phases. So these are the three types of foreign rock matter incorporated by the magma, right? So factors affecting assimilation. So first one is temperature of the magma at the time of the intrusion, and second one is presence or absence of notable degree of heat, and composition of inclusion in concentration of volatile in magma and condition which facilitate or retard the escape of volatile into the surrounding rocks, right? So some of the examples here, right? So you see the conclusion. So this assimilation is the process of reacting of the magma with the wall rock, right? You remember this word, wall rock, right? Reacting of the magma with the wall rocks, whereby the country rock are incorporated in the magma and eventually melting process. So as magma passes upward through the crushed pieces of the country rock through which it passes may be broken off and assimilated by the magma. And assimilation required large amount of heat that is to takes place. So contamination of magma by country rock, it may contribute xenoliths and xenocrysts. So that is to the magma. So, and melting, diffusion and reaction. So these are the process of assimilation. You remember this: melting, diffusion, reaction, right? So these are important in assimilation. So this is the origin of igneous rocks, that is differentiation and assimilation. So this is very important things in origin of igneous rocks, right? Okay, today class is over.